Welcome back to another video on the channel. In today's video we're going to be taking a look at question 8 from the 2023 external exam for specialist mathematics, paper 2. Now you would have noticed on the channel I've started splitting up each question into its own video. That way I can go into a bit more depth on each question, and it also gives you a bit of variety in terms of, like, if you only struggle with question 8 and question 15, etc., you can go watch those in the playlist. The full exam video is still up on YouTube. The link is in the description below, so if you're still interested in that. If you need a specialist external exam bundle pack, the link is in the description below for your download. But otherwise, let's just get straight into it. And if you have any questions at all during the video, leave something in the comments. Okay, so question 8. Given f of x equals inverse tan of 2x, determine f dash of 3. So to answer this question, we are going to be using this formula here. If I can get it onto, oh, I just got rid of that. Let's try that again. Here we go, let's try that one more time. We're going to be using this formula here, okay? Now there is another formula you can use, however this is what they provide in the specialist formula sheet. So I'm just going to show you how to use it with the tools you'll probably get given in the exam. So first of all, if it is 1 over a, it's quite easy to differentiate. Now at the moment it doesn't look like that at all. However, it just depends on how you're looking at it. So here, if we're looking at this guy here, so tan inverse of 2x, it is given in that format, however, it's not obvious. So here, what we've got to ask ourselves, 2 is going to be equal to 1 over a in this case here. So we've got to work out what a is. Therefore, a is probably going to be equal to, in this case here, if we were to flip the whole thing upside down. So 2 is the same as 1 over a half. So in this case here, my a value should be equal to a half. A way you can double check that is to solve for a with this expression here. You multiply both sides by a and divide both sides by 2, and you get a is equal to a half as well. So in this situation here, the a is equal to a half. So realistically, we're being asked to differentiate tan inverse x over a half. Now that becomes a little bit easier to use, because now we know exactly where the pieces are going to fall into the formula. So here what we do is just sub it in. So at the top there, you're just going to have the a, which is a half, divided by a squared. So it's going to be a half squared plus x squared. And what we're going to do is sort this out a little bit. So here you have f dash of x equals a half. Oh, I kind of botched that a little bit. We'll just copy and paste that actually. Oh dear. Let's try that again. There we go. So that's f dash of x. Now I'll get rid of this stuff over to the side there. But that's the best way to do it with the formula sheet version of the formula. There is another one you can use, but it's not on the formula sheet. Alright, what I would do before we do anything is tidy this thing up. So this 2 can go down the bottom there, because if we're going a half times by something, you can move that 2 down the bottom. So in this case here, you have f dash of x equals 1 over 2 times by this entire expression. Now a half squared is going to turn into a quarter. So then you've got plus x squared there as well. So this will turn into 1 over 2 times by a quarter plus 2x squared. So in this case here, that's going to turn into 1 over 2 over 4 plus 2x squared. Now if we really wanted to make this even better, we could try and turn this into a whole number. And the only way you would do that is by timesing the top and bottom by 2. So if I times the top and bottom by 2, technically I'm not changing anything, I'm just changing how it looks. So the reason why this would be good is because you multiply to there, but all of a sudden that turns that into 1, which is no longer a fraction there. Now you don't have to do this, however, if this was a short response question, I would definitely recommend this, because it's the only way you'd be able to do it if it was a short response and you had to demonstrate all your working. So here, you would get 2 over 1 plus 4x squared. And if you don't believe me, if you try to differentiate that, it would turn into your exact answer. But also you've got to remember is this. You have your calculator with you as well. So here what we're going to do now, because that is f dash of x, we're going to chuck in x equals 3 now. So in this case here, we're going to be working, so f dash of 3, we'll get rid of that. The computer is not liking me today, but that's okay. So here you're going to replace 3 in there, so 2 over 1 plus 4 times by 3 squared. And if you don't get the right answer here, you could have just done it in your calculator the whole time. Okay. Now this gives us approximately 0.054. So here, if we're looking at our answers, the best answer is going to match this guy here. Okay. Now what I would do is also check your grapher as well. So what I'm going to do on my calculator in person here is I'm going to double check my grapher as well. So I'm going to graph tan inverse of 2x, and I'm going to type in, well, first of all, I've got to put it in shift setup, put it in radians for it to work. Go trace, and then x equals 3. And yes, I get the same answer as that. So that is 100% correct. And anyway, that's how you do question 8. Right, was this a hard question? Not really, because it's a calculator one. Would it be hard if it was a short response and you had to do all this working? Absolutely. If you have any questions at all with this one here, leave something in the comments. If you're interested in the Specialist External Exam Bundle Pack, the link is in the description below. But otherwise, I'll see you in the next video.